Welcome, everyone, to this explainer. Today, we're diving into what I honestly believe is one of the most gripping intellectual detective stories in all of human history. We aren't just going to look at a dry, boring timeline or memorize a list of ancient philosophers. No, we are tracking how human beings literally mapped thought itself. You see, the history of logic is really the history of our changing ideas about truth, reasoning, knowledge, and language. From ancient thinkers arguing in city squares to the exact code running in the device you're using right now, this is the ultimate story of how we learn to think about thinking. Okay, let's jump right into the deepest, most foundational question we can ask. What exactly is logic? Well, if you ask different intellectual traditions throughout history, you're going to get wildly different answers. Is it the psychological study of human thought, or is it purely an analysis of language and the words we use? Is its ultimate goal to find absolute truth? Or is it just about making sure an argument is structurally valid, even if the actual premises is totally ridiculous? Or maybe it's the exact pathway to generating true knowledge. Keep these questions in the back of your mind, because as brilliant thinkers wrestled with these exact definitions over the centuries, their shifting answers literally changed the world. Here is our roadmap for today. We'll start with what logic actually is. 2. Ancient Greeks and Aristotle. 3. Indian traditions of logic. 4. The modern scientific era. And finally, 5. Mathematical and formal logic. Section 1. What is logic? The quest for certainty. To really understand this massive evolution without getting totally lost in the weeds, we need a solid academic framework to analyze every era we visit. So, to do this impartially, we're going to use a 5-question framework. For every single tradition we look at, we won't just ask, what did they say? Instead, we'll ask, what was the specific intellectual problem they were trying to solve? What was their core concept of logic? How did they structure inference? How did they get from point A to point B? What did they keep or reject from the thinkers who came before them? And finally, what was their impact on the future? By doing this, we treat each new era as a direct, brilliant solution to the previous era's problem. Section 2. Ancient Greeks and Aristotle. Organizing the chaos. Picture the ancient Mediterranean world. Before Aristotle even comes onto the scene, you have these pre-Socratic thinkers like Parmenides and Zeno pointing out massive, literal headache-inducing contradictions in how we perceive reality and change. Then Socrates and Plato enter the chat, using intense back-and-forth debate to chase down the definitions of concepts. They were dealing with a huge intellectual crisis. Is human experience alone enough to find the truth? Or do we need strict rational rules to separate genuine, rock-solid knowledge from just having an opinion? They realized they desperately needed a system. Enter Aristotle. He steps in and creates the very first structural rules for reasoning. It's an absolute game changer. He builds a 5-step architecture. First, he starts with a term, like Socrates, then a proposition, like Socrates is human. Next is the famous syllogism, where you combine statements. For example, all humans are mortal, Socrates is human, which then leads unavoidably to step 4, the conclusion, Socrates is mortal, and finally, demonstration, which is how we actually prove it scientifically. Aristotle didn't just want to win arguments in the town square. He built the actual machine to evaluate all arguments. But, logic didn't just stop with Aristotle. A bit later, a massive shift happened with the Hellenistic and Stoic philosophers. Aristotle's logic was what we call term logic. It focused heavily on categories and individual subjects. The Stoics, however, shifted to propositional logic. They focused on how entire statements connect to one another. Think about conditional statements like, if it rains, then the ground is wet. It is raining, therefore the ground is wet. This pivot from categorizing subjects to analyzing these if-then conditions was a huge intellectual leap. And actually, it laid the exact conceptual groundwork for modern computer programming. How cool is that? Section 3. Indian Traditions of Logic. Parallel Brilliance in the East. Now we're shifting our focus geographically, because it is absolutely vital to understand that Indian logic developed completely independently from the West, and it's just as brilliant. The Nyaya school, for example, developed this incredible 5-part model of inference. It starts with a proposition, the mountain has fire. Step 2, the reason, because there is smoke. Step 3 is the example, where there is smoke, there is fire, like in a kitchen. Step 4 is the application, this mountain has smoke. And step 5, the conclusion, therefore it has fire. Do you see the structural parallelism with Aristotle's syllogism, yet it's uniquely grounded in direct, real-world observation? It brilliantly weaves empirical, everyday examples directly into the logical structure. And the Naya school was really just one piece of a vast, incredibly sophisticated puzzle. Diverse Indian schools expanded logic way beyond just winning a debate. You have Vaisheshika, which tied logic directly to physical reality. Buddhist logic rigorously analyzed what actually makes a reason or a cause valid. Jain logic introduced this absolutely mind-bending concept of anekantavada, the idea that reality is multi-sided, meaning truth can be conditional based on your perspective. And Mimamsa dove deep into the philosophy of language, analyzing how texts actually generate knowledge. These weren't just debate rules, they were highly advanced systems for understanding reality. Section 4. The Modern Scientific Era. Logic Meets the Real World. As we transition into the modern era, a completely new problem emerges. The scientific revolution is exploding. Philosophers are suddenly looking around and asking, wait, how does logic adapt when we no longer just want to win philosophical arguments, but we desperately need practical, universal knowledge about the physical universe? Francis Bacon steps up and champions induction, arguing we have to build logic from the ground up through direct scientific observation. Descartes swings completely the other way. He wants pure mathematical certainty. He wants to doubt everything until he hits an absolute, undeniable truth. Then you have the empiricists, Locke, Hume, and Mill, tackling the messy reality of human experience. Hume famously raises the problem of induction. Basically, just because the sun rose every day in the past, how can pure logic actually guarantee it's going to rise tomorrow? Logic was no longer just about writing valid sentences. It was suddenly about securing undeniable scientific truth. Section 5. Mathematical and Formal Logic. Stripping away natural language. So, as science advanced, thinkers realized there was a huge, glaring flaw in all of our logical systems up to this point. Natural human language is just incredibly messy. It's ambiguous, it shifts in meaning, and it's full of emotional baggage. This created a massive new problem that required a radically new solution. It led to a revolutionary dream inspired by thinkers like Leibniz, who basically asked, can logic be organized like computation? He wondered, what if we could take our messy human thoughts, convert them into pure symbols, and calculate the truth the exact same way we calculate a math problem? Imagine a world where two philosophers disagree, and instead of shouting at each other, they just sit down and say, let us calculate. So the crucial point to take away here is that during this phase, driven by brilliant mathematicians like George Boole and Augustus de Morgan, logic officially became a branch of mathematics. Formal logic stripped away words entirely. It completely replaced natural language with algebraic structures, variables, and strict computational rules. Literally, human reasoning was translated into symbolic equations. And this sparked an absolute revolution in the 20th century. Gottlob Frege introduced formal languages and quantification. Bertrand Russell and Alfred North Whitehead took on this monumental task of trying to prove that literally all of mathematics could be perfectly built on a foundation of pure logic. Wittgenstein intensely analyzed how our language precisely maps to the structure of reality. And David Hilbert pushed for fully formal, axiomatic systems. Together, these minds were basically trying to map everything in the known universe into a perfect, unbreakable mathematical machine. But then came the ultimate plot twist. Kurt Gödel. Gödel dropped a mathematical bombshell. He mathematically proved that any formal system complex enough to do basic arithmetic will always have statements that are undeniably true, but fundamentally unprovable within that system. It was shocking. He completely shattered the dream of a perfect, all-encompassing logical machine. He proved that logic has inherent boundaries, and that truth itself is actually a bigger, wider concept than pure proof. When we take a step back and neutrally compare the ultimate philosophical aims of the two great traditions we've explored today, a really beautiful picture emerges. Western logic historically steered toward analyzing valid inference, building scientific methodology, and eventually hunting for pure formal mathematical proof. Meanwhile, Indian logic consistently aimed its highly structured systems at generating true knowledge, diving deep into epistemology, and grasping the ultimate nature of reality. We're looking at two distinct lenses, equally brilliant, solving profound intellectual problems in parallel across the globe. So look at this incredible historical arc we've traced today. Step 1, the messy search for truth through ancient, spirited dialogue. Step 2, creating the very first structural rules for valid inference. Step 3, adapting logic for the massive demands of the scientific method. Step 4, translating human thought entirely into formal mathematical systems. And finally, step 5, discovering the absolute mathematical limits of those very systems. It is just a continuous, absolutely beautiful evolution of human thought. Which brings us to a final, really provocative question to leave you with today. Right now, we're seeing an explosion of new logical systems, multi-valued logics, modal logics, and even mind-bending quantum logic. So we really have to ask, is one single type of logic actually sufficient to explain all types of reality? As our understanding of the universe continues to expand, it's clear our logic is going to have to expand right alongside it. Keep questioning, keep learning, and thank you so much for joining me on this explainer.